Hey everyone, welcome to the Let's Create series, a series where we'll create mechanics from popular games using blueprints. Today we'll be creating Zarya from Overwatch. We'll be focusing on her Graviton Surge ability. If you're new to this series, make sure to watch the foundation videos which are linked in the description below. We're going to start off by creating the ultimate projectile, and then we'll move into the character, and then the physics objects that will fly around once you have casted the ulti. So to begin, go into blueprints, and we're going to create a new blueprint. Right click, create a blueprint class, and the projectile is going to be an actor. We can call this the BP underscore Zarya ulti projectile, and open that up. Once you're inside, we're going to create a sphere. So click on add component and type in sphere, left click, and it's probably going to be a bit too big, so let's halve the size, 0.5 overall. I press tab to skip through. Let's compile that and just double check. So we could probably make it a little bit smaller than that, maybe 0.3, and that should work pretty well. So I'll just delete that out of the scene. And once you've created the sphere, we can create the projectile. So if we go and type in projectile, we get the projectile movement. If you haven't used this before, it will allow your object, our actor in this case, to move. So the projectile movement has a bunch of great components attached to it, if you see here, where you can get the speed, max speed, whether it should bounce, a bunch of really amazing things, homing projectiles. If you haven't messed around with this, I highly recommend checking this out. If you go into the initial speed, we're probably going to have this set to 3000 for now, which is quite large, but we're going to have gravity as well. So set the initial and max speed to 3000. If you want to at gravity, set this to 0. If you don't want gravity, set this to 1 if you do. We do want gravity in this case. We can make it bounce if we like. It probably won't last long enough to bounce, but if you want to increase the lifetime of the projectile, put on should bounce, and then it can bounce off a wall, and then the ulti will cast after that. And then for the velocity, we're going to make this 3000 on the X and 0 on all the other axes. And that's it. So now we can go on to the other section of this projectile, which is creating the collision. And the way we're going to do that is by creating a new component. We'll call this the sphere collision. And we're going to name this the physics object detection. Oops, detection. Just going to unparent that. And the radius we set here is how far out it will detect physics objects around it. So depending on the radius you want for Zarya's ulti, you can set this number. I found a value of around 800 works really well, and you can of course make it bigger if you like. Hit compile and save. And apart from setting the radius, we need to make sure that our collision is set up properly. We want to make sure it is overlapping all dynamic, and we need to tick simulate generate hit for physics, and that is it. So hit compile and save. The next thing we're going to do is create the Zarya character. So you can close this blueprint now, go to the FPS controller, right click, duplicate, and call this the Zarya character. If you are not using this template, which I highly recommend you do if you haven't watched the video, you can just take the FPS controller, open it up, and get rid of any components that aren't here. All we're doing in our character, which we set up in the other video, is movement, jumping, and mouse input. Once you've got your character, go into the viewport, and we want to create a new scene object, which will be our projectile position. So this is where the ulti will cast from. I'm going to drag it somewhere around here. So I have it at a height of 40 and a distance of 60. So you can copy those. into your location up here, and I'm going to call this the ultimate cast position. I'm going to compile that and save it, and you can make that a child of the camera if you like. It should work here, but I'm going to make it a child of the camera for now. That way, technically, if it rotates, it'll rotate the position with it. Once you've made the ultimate cast position and the projectile, we have an actor we can spawn and a position we can spawn the actor in. So now we can get into the blueprint section of this. The only other thing we need is to make sure we have a button input for the ultimate. So go to settings, project settings, go down to input, and in your action mappings, we want to see, so we don't have an ability for ultimates, which we're going to use Q for. So we're going to make a new action mapping. We're going to call this ultimate ability. Click on none, and we're going to assign the key to Q. So now when you press Q, it will be for the ultimate ability, and we can call that inside of the Zarya character. So right click, ultimate ability is what we're after. And now we can set up all the functionality for spawning the projectile. So this first section is spawning the projectile. We need to have a variable, which is going to be a boolean. And this boolean is can shoot ultimate. By having this boolean, hit compile. By having this boolean, we can check if we can or cannot shoot the ultimate. So get this boolean, drag out and type in branch, go from pressed into the branch, and the first thing we want to do is set can shoot ultimate to false. That way we cannot spam the ability straight away. After that, we want to drag out and spawn an actor, which is that projectile we created earlier. So select class, BP underscore, and that's why I named it BP underscore, so we can easily reference it, Zarya ulti projectile. The spawn transform will be the ultimate cast position, so drag that down. And we want to get world transform. We can then plug that into the spawn transform. And the next thing we can do is add a delay. If you're wondering what this delay is for, it is the time before we can shoot again. Because after this delay, we're going to set can shoot ultimate back to true, and it can loop through this again and again and again. If you want, we can create a variable for the delay, and what we can do is go to the duration, right click, promote it to a variable, and then drag that down here. We can name this variable the ultimate cooldown. Hit compile, save, and now we can give this a time. So let's say for now, while we're testing, maybe something like 5 seconds. So it will check if we have pressed Q, it will check if we can shoot the ultimate. If we can shoot it, set it to false, spawn the projectile at this location, and specifically spawn the Zarya ulti projectile, have a short delay, which is the ultimate cooldown, and then allow us to shoot the ultimate again. So in Overwatch, you have to charge your ultimate, whereas here we're just having a short delay. So let's drag these, make it a bit more compact. Select all of the nodes and press C, and now we're going to call this the shoot ultimate. That way we easily know what all these nodes are doing. And we want to make sure we can shoot the ultimate from the start of the game, just because we're testing. As I mentioned before in Overwatch, shoot ultimate would become true once you have charged your ultimate ability. The next thing we want to do is create the ultimate functionality, and before we do that, we can quickly test if this is working. So minimize, hit play, and before you hit play, make sure you go to settings, or not settings, go to FPS game mode, and change our default pawn class. So last time I opened this project up, we were using Gordon Freeman. Now we're going to use Zarya character, compile and save. Now it will spawn Zarya character, hit play, and press Q and short delay, press Q again, it shoots out, there'll be another small delay, and I can press Q again. So this is working. Now we can create the ultimate functionality, and what we want to do is make sure that the projectile will stop in midair after a certain amount of time. I'm doing a certain amount of time. If you want, you could make it based on a collision, but a certain amount of time, a short delay, is the easiest way to show this off, and then you can create more functionality after. Right click, we're going to get an event, begin play, and we're going to set these things at the start. Oh, actually, I am in the wrong blueprint. In order to create the ultimate functionality, we should actually be in the BP_Zarya ulti projectile for this bit. So delete these two and keep the event begin play, drag out, type in delay, and this delay is the time before the gravity pull will occur. So right click on duration, promote it to a variable. It's a bit hidden. Then this variable will be called the time before gravity pull. Now for testing purposes, we're going to make this quite short, something like 0.3 seconds. After we've set the gravity pull and it has a delay, we need to set the visibility of our sphere so we can no longer see it. So set visibility sphere and leave it unticked. That way, that means it's false and we will no longer be able to see it. We then want a variable called set can check. You'll see what the use of this is once we are getting into the collision checking. But for now, we're just going to keep this here and set it. So we're going to set can check to true. And I'll explain what can check does once we have our collision set up. We also want to stop movement immediately. And this will stop the projectile from moving. It'll basically make, if you go to projectile movement, the initial and max speed, it will set everything to 0. The only thing we need to set to 0 ourselves is the gravity scale. So we're going to stop moving the projectile. Then from projectile movement, drag out, which will give us access to set projectile gravity scale, as you see down here. We can drag this into that node, and now the projectile gravity scale will be 0, so it won't fall. It will stay where it is. We then want to have a delay, one more delay. And this is the delay before we destroy this entire projectile. So this is really the lifetime of the ultimate. So if you want, you can right click and promote this to another variable and call this ultimate lifetime. We're going to set this to 4 for now. And then, of course, we're just going to destroy the actor, which will get rid of the ultimate and stop all the functionality from occurring. So we're going to highlight, press C, and then this will be the stop moving and allow can check. So that's what this is all doing. And of course it has the lifetime. The next section is to detect objects and add them or remove them from an array. So we're going to use our physics objects detection. So click on this, and there are 2 ways we can go about this. You can scroll all the way down and select one of these options, or we can just right click and type in on components begin overlap. Once we have this, we can check if the other component is simulating physics. The reason we want to check if the other component is simulating physics is because we are going to add force to the objects within the radius of Zarya's ulti. If the object is not simulating physics, we can't add force to it anyway. So basically this allows us to check what we can bring into Zarya's ulti. So go from other components, drag out, is simulating physics, this will give us a return value which we can plug straight into a branch. So if you see here, if it is simulating physics, it will be true, which will allow us to do something, whereas false, obviously, it's not doing anything. To make sure that this is all working, we want to do a print string, and here we will type in physics object added. Then we're going to go to other components and we're going to create an array. We need the data type to be the same as other component, so we're going to right click and promote to variable, which is going to save us a lot of time. We can then delete this. We can go to this new variable, make it an array by clicking here and going to the array, and then we can call this, what are we going to call this? Let's call this our objects in ultimate. So what objects are within the ultimate? We can hit compile and save that, and now we can drag this out and get this. And over here, every time we overlap a new object, let's add to our objects in ultimate. This is going to make our array bigger and will allow us to actually store the objects that we collide with and add physics to them. So we're going to drag out, type in add, drag to this node, and you'll see that it requires a new item, which is the other component. And if you want to clean this up a bit, we can double click here, which will create a reroute node, double click here, and you can drag these out and make it a bit neater, and you can bring this up if you like. However, we're going to use this again, so I'm going to leave this here for now. So now we're going to be adding objects in. There is another part, which is to remove objects. So you can click on the physics object detection again, and instead of begin overlap, right click, end overlap is the function we're after, the node we're after. And we're going to do a very similar thing to up here. So other component is simulating physics, because we're only going to remove the objects that are simulating physics. We have a branch, and if this is true, all we have to do is first check, so print string. This is just for debugging. You'd get rid of these for the actual game. Physics object left or removed would be a good thing to say. And then from here, we can drag out from our objects in ultimate and type in remove. Remove item, drag out here, and just like up here, we can get our other component, plug that in, and double click and move these down. So let's go over this again and test it out. This begin overlap will add objects to our array that is simulating physics, which will allow us to add physics to them and manipulate them with impulses, forces, and all that stuff. This one will remove them. And the reason why we want to remove is because there is a time before we gravity pull. So if our gravity pull goes past an object that has physics and it gets out of its radius, we want to remove it. That way, if a character runs through our collider here and say they move all the way over to this space, we don't want to just pull them back, because that's quite unfair, because this is the radius for Zarya's ulti. But if they're within the radius and they haven't left, then of course we're going to pull them in. That is why we have this check here. We can highlight all this, press C, and then detect objects and add or remove from array. And I'm just going to line this up, compile and save that. And in order to check this, we need to have some physics objects we can move around. Now I'm going to show you something we haven't really messed around with before. We have some physics objects here, but I'm going to actually just delete these. We're going to create a new blueprint. So right click, blueprint class, actor, and this is going to be our BP underscore master physics object. The master physics object, if we open that up, it is going to be what our... Actually, I'll describe that a bit later, the bit of it about inheritance. But basically, in our master physics object, we're going to set up a bunch of properties, and then we're going to create child objects. The child objects will inherit anything we change here or add, and it will allow us to have unique children objects. And anytime we want to make a mass change to all of them at once, we just change the master physics object. And I'll explain how that works through showing you guys. So if we were to add in a mesh, so let's add in a cube, and we're going to call this the mesh. Maybe make the cube 0.5 for now, just halve it. I'm not sure how small that is, but we'll see after. Now remember the component, so this is the component, we need it to simulate physics. And let's tick simulate generate hit event just in case, because I had a few problems when it wasn't doing this earlier. And compile and save. Let's drag this out, and first let's make sure that this is working. So we'll just drag these out. Just drag 3 of them out. We're gonna hit play, press Q, and there you go. So physics object added and removed, and they also fly away. So they have proper physics added to them. I'm actually going to reset these to 1 as they're a bit too small. And I'll just drag these out. Awesome. So now this is the base, right? And we have a certain mass that this object is and has certain dampening properties and all this great stuff. What if we wanted to have objects like this with different properties, but we wanted to easily edit all of them together? So what if eventually we added unique blueprints to our master physics object, but we wanted other classes to inherit from it? The easiest way to do that is to right click on the BP underscore master physics object and create a child blueprint class. We'll call this BP underscore child chair. And the reason I'm calling it chair is because I believe we have imported the content pack, the starter content pack, which has a chair in it. So we created BP underscore chair. Now this is a child of BP underscore master physics object. So anything we change here will inherit here. The great thing is we can also just have some unique properties that we don't have to inherit. In terms of making this visually different, let's go to the cube and type in chair, sm underscore chair. And if you don't have that, as I mentioned, make sure you go to add new, add content or feature pack, and import the starter content. Now that we have the chair, we can hit compile and save. And let's drag in the chair. And it'll be picked up and then removed if it gets knocked away. And if later on we created a bunch of blueprint functionality, the chair will inherit all the functionality and we can add some unique properties to it. The reason I did this is because I wanted to show you all the child, how the child works. And in case you want to take this tutorial further and make a bunch of child physics objects and do a bunch of unique things. Now that we have the physics object set up, we can go back to the ulti projectile and do the final bit of functionality. The pulling effect is quite simple, and there's a lot of room to change it and make it even better. So for the final section, we're going to use the thing people dread the most, an event tick. And then we're going to branch out, so branch. Now, if can check is true, that means the ultimate has started because this is stopped. It's no longer gravity. All of this is happening. So we can get can check, get, and check if it's true. If it's true, we're going to have another branch. And what we're going to do is check if the array is empty or full. The reason we're checking that is because there's no use in adding radial impulse to objects that don't exist, and we'll probably get a bunch of null reference errors. So drag out the objects in ultimate, get, and then drag out and get last index. We can then check if the last index is greater than or equal to 0. And drag out here. So if the last index is not greater than or equal to 0, that means there's actually nothing in the array. That is why we're doing the greater than or equal to check. From here, we can drag out and add radial impulse. Now, before we add it, this is limited because it's only adding it here. Our target is actually not the object itself, like this projectile. The target is from the objects in Ultimate. So we need to drag this out and type in add. Should be able to add radial impulse from that. Add radial impulse. I'm going to get rid of context sensitive and type in, there we go, add radial impulse. Drag that to true, and then we can double click and make it a bit neater. You'll also notice that these change depending on what it is, because it's an array, it comes up with these, if you're curious about the difference between those two. The origin point is where the projectile is, so we can quite easily just get actor location, which is where the actor is located, drag that into origin, and then we need a radius and strength. This is really cool, so let's go for a radius of 500. Now, if I was to make this something like 75 and set velocity change, all the objects would fly away, and I'll show you how that works. So select velocity change, that way the mass is not an effect, which basically means we don't have to type in a crazy strength value. And then I like to use linear. It looks a bit more realistic, but if you want it to be a constant force, select constant. All right, let's hit compile and save, and I'm going to show you a few things about why we're going to make this a negative 75. So if I just minimize that, hit play, and press Q, you'll see it pushes all of the physics objects away. So press Q again, pulls them away, right? Pushes them away. So all we have to do is type in -75, hit compile and save, and you'll notice, I'm just going to press F11 to full screen this. If I press Q, it'll pull all the objects towards it, and then when it destroys itself, they'll all fall apart. Press Q again, pulls them, they fall apart, and that's the Zarya ulti. It's pretty simple to set up, and it's really nice. You can do a lot of cool stuff with this. You can make them orbit more, you can make the objects rotate, you can apply damage to them. You could also, once the ulti is complete, launch all the objects and make them fly away. It depends on what you want to do. But in terms of what we're accomplishing here, we just wanted to bring all the objects together. So now we can just highlight this, press C, and type in pull and move objects. And those are the three things we needed in terms of blueprints. So compile and save that. And that is it. We have the whole setup done. You can hit play, press F11 again, press Q, and all the objects will fly towards it. We can try and make this a bit more crazy. So let's select this. I'm just pressing Alt, then I'll rotate them and bring them up. Hit play, Control P, press Q, and all the objects are going to fly around and then go away. And as you can see, the objects are removed from the array. Once again, added. Now technically it doesn't matter after the physics, after we've pulled them, to remove them from the array because we're destroying the object. As I mentioned before, it's if the object, the projectile, goes past all these that we want to remove them. Q again, and that's it. It's quite simple. The pseudocode was pretty simple. You could also try achieve this with a line trace by sphere. I opted to go for a simple collision event, which I really like. I like working with these. But if you want, you could try and use the line trace by sphere if you want a little bit of a challenge. Thanks for watching, everyone. I'm so happy to finally get Zarya done. When I started this whole series a few months back, I was working on Zarya and trying to get it working, but I wasn't good enough at blueprints at the time to get the functionality in. So I ended up creating that Genji video instead. So it feels good to finally get back to it and finish off Zarya And now I know I can create Zarya. It's awesome. I hope you enjoyed this video. If you do enjoy my content, do consider supporting me on Patreon. It really does support the channel a lot. There's a bunch of new equipment I'm going to get soon, which is going to make my recording a lot easier. So all that Patreon support goes directly into the channel and makes this a lot better. For similar content, make sure to subscribe. Thank you all for watching, and I'll see you all in the next video.